Hello everyone. Today we are discussing intersection point in Y-shaped linked list. So let's get started. The problem states that given two linked lists N and M, we have to write a program to get the point where two linked lists intersect each other. So we can see an example that the first linked list is 369. Then we have 15, 30 null as the common. And then we have second list as 10, 15, 30 null. So we can see the intersection point would be 15 here. So we return 15. So in next example, we see 4, 1 common, 5, 6, 1 common. So the common node is 8 here. So we return 8. Now here only common is depicting that some common list is there. This common list is not given separately. Otherwise this would be a simple question and you can just return the head of the common list. Now we are given head 1 and head 2. So we are given two lists, this and this. Here common is written so that we can understand it better. So our task is to complete this intersection point function and return the data of the node, which is the intersection point. So let's try to have it how to do it. So finding the approach, we can see that the both lists are having different number of elements. So first we can calculate the number of elements each list have. Suppose this is head 1 and this is head 2. So it is H2, it is H1. Now we calculate the number of nodes here. So it will be 1, 2, 3, 4 and 5. So we have total 5 nodes in head 1. In head 2 we have 1, 2, 3. So 3 nodes are there in the list whose head is head 2. Now what we can do is we can find the difference between the two. So 5 minus 3, which is 2. So till 2 elements we would move head 1 so that head 1 and head 2 reach the equal level of elements. We are calculating the level from the null pointer. So here is a null pointer. So what we want is from null pointer head 1 and head 2 should have equal number of elements. So we move head 1 to head next till we do not reach the level of head 2. So we want head 1 to be placed here. So we move head 1 to head next. So it will move 3 to 6. So head 1 will be placed here. And then this is not the same level, so again we will move head 1 here. Now what we can see that we have equal number of elements after this for both head 1 and head 2. And how many times we have moved head 1 to head next is basically one from 3 to 6 and other from 6 to 9. So 2 times. Hence the difference which we are calculating, that much times we would be moving the head to the next element. Now we have reached the same level. Now we will start traversing from both the sides. So we will move head 1 and head 2 together by comparing if head 1 is equal to head 2 or not. So here head 1 is not equal to head 2. We move both of them to the next one. So this is head 1, this is head 2. Now head 1 and head 2 become equal, so we return the head 1 data or head 2 data, and hence the output is 15. Now we can see it in the other example also. Let's check this example. So here we have first list as 41845, next list as 56145. Now we calculate the number of elements. 41845, it is 5 elements, and 561845, it has 6 elements. So the difference is of 1. Now which is having the bigger more number of elements? This list. So we can have head 1 and head 2. As I was moving in previous example head 1 only, hence I have defined head 1 for the larger list. Now we move head 1 by 1 unit. Now we will move head 1 and head 2 together. So head 1 will be this, and head 2 will be this. Now if we compare head 1 and head 2, they are not the same, as the data is same but the node is completely different. So both are 1 but the node is not same, hence head 1 is not equal to head 2 and this is not the intersection point. Now again we will move head 1 and head 2 1 unit. So this becomes our head 2 and this becomes our head 1. Now head 1 becomes equal to head 2, so this is our intersection point. So I hope you guys understood this approach. Now let's see this approach through the code. So here is the C++ code. First what we are doing is we are finding the length of both the list. So C1 is the length of head 1 and C2 is the length of head 2. Then we calculate the difference as G. If C1 is less than C2, we swap head 1 and head 2, as we were having the larger list head pointing to head 1. So head 1 is the head of the larger list always. For this convention, we are comparing C1 and C2 and swapping if needed. Next, what we are doing is till D number of movements, we are having head pointing to head next, so that we reach the same level of the nodes as we discussed in the two examples. After reaching to the same level of the nodes, we are comparing head 1 and head 2 and then returning head 1 data if the nodes are matching, otherwise both are moving to the next. And if the head 1 and or head 2 become null, which means we do not find a node which is the intersection point. So after this condition, we would return a -1 here, which means there was no intersection between the two linked lists which were given. So let's run the example through the code. Let's run this example only, which is 41845 and 561845. So we have C1 equal to length of head 1. First our head 1 is this. So we calculate the length, which is 1, 2, 3, 4, 5. So C1 is 5. And our C2 is 6. Now C1 is less than C2. So we swap the two heads. So this will be our head 2 and this will be our head 1, and our D is absolute of C1 minus C2, which is 1. So while D greater than 0, head 1 point to head next. So head 1 is pointing to head 1 next, head 1 point to 6, and then D minus minus, so D is updated, which becomes 0, and hence the loop breaks. So we have H1 pointing to 6 and H2 pointing to 4. After this, we check that head 1 is not null, head 2 is also not null. So we compare head 1 and head 2. Head 1 and head 2 are equal or not. Here they are not equal. So head 1 will move to head 1 next. And head 2 will move to head 2 next. Again, head 1 and head 2 are not null. Head 1 not equal to head 2. So they both move to the next element. Now we see that head 1 is not equal to null, head 2 is also not equal to null, and head 1 becomes equal to head 2. Now we return here head 1 data. So hence head 1 data is returned and we get the output as 8. So hope you guys understand this code also. Now let's compile and test this code. So the compilation is running fine here. Let's submit and check. So the code is working fine. Hope you guys understand the approach and the solution as well. Thanks for watching.